A typical RAG system consists of two phases. In phase 1, documents such as the chunks are added to the vector database. In phase 2, the user issues a query to the vector database first. The database determines the closest chunks and returns the chunks along with a prompt which then get added to the context. The context is sent to the LLM and the LLM responds to the user with the extra context and the chunks returned from the vector database. Today, we're going to are the same as the OpenAI models. Feel free to replace this with your OpenAI model definitions if you'd like to use OpenAI. Next, we're going to define our chat model. Okay, now that all of our models are defined, we can save and close this file. Next, in Visual Studio, create a new Python file and name it ingest.py. The most important imports here are the PyPDFLoader, the RecursiveCharacterTextSplitter, as well as Chroma. These are the three key classes that we're going to use in order to ingest our files into Chroma. We're also importing the models class that we created earlier. Next, let's initialize our models. So we create two variables here, embeddings and LLM, that will be used in our ingestion process. Once this is done, let's define our constants. In this case, our data folder will be ./data. Our chunk size will be 1000. Overlap will be 50. And the checking interval for ingestion will be 10 seconds. Now, let's define our Chroma vector store. And for this, we're going to initialize the Chroma class by giving it a collection name and the location where to store the database. In our case, that will be in the ./db chroma_langchain db file. Now, let's create a method for ingesting of our files. This will be a utility method that will be called later on in the loop. First, we're going to skip all files that are not PDF. Next, we're going to use PyPDFLoader to load the PDF file and use RecursiveCharacterTextSplitter to chunk the PDF files into sections that can later be used in the vector database. Next, we're going to create a set of documents by using the split documents method of the splitter. Next, we're going to create a set of unique identifiers. And finally, the most important command will be vector store.add documents, where we pass the documents as well as IDs. This is the command that will add our document chunks into ChromaDB. Now let's create our main loop. So let's see what's happening here. The main loop is a while loop, and while it's true, it's going to check the data folder for all files that do not start with underscore. The reason we're doing this is so that we don't ingest the same file twice. Once the file is ingested, it will then be renamed to start with an underscore. And it will sleep for the time interval and then check again. In this case, every 10 seconds, it will run a scan in that folder for new PDF files. Once the main loop is ready, we can start running our app. Okay. So that is the whole ingestion file. The main logic happens inside the ingest file method. We're using PyPDFLoader with the PDF file path. We're splitting it with the recursive character splitter. And then we're using vector store add documents to add this to Chrome. Save this file. And now let's move on to our next task. Now let's define our chatbot interface. In Visual Studio Code, create a new file and name it chat.py. Inside that file, we're going to write the logic that will call the vector store and enable the user to have a conversation with the PDF file. Let's start with our imports. So once the imports are done, let's initialize our models. This is very similar to what we did in the ingest file. We're going to use the same models that we defined in our models.py. Next, let's initialize our vector store. The vector store will follow a similar format to what we defined inside the ingest file. We're going to use Chroma. The collection name must be consistent with the one that we used during ingestion, and the directory must be the same directory. Once that's done, let's work on our prompt. We use a very simple prompt with one system and one human message. And inside the human message, we take the question as input and pass the context so that the RAG outputs are appended to the context window. Next, let's define our retrieval chain. Now this part is very important. First, we define our retriever as vector store as retriever. This is where we pass the k number of documents returned. In this case, we're passing number 10. Then we combine the docs into a create stuff documents chain method by passing the LLM and the prompt. And then finally, we create a retrieval chain by using the method create retrieval chain by passing the retriever and the combined documents chain. The main loop will be a while loop that will iterate and ask for user input. As long as the user input is not Q, quit, or exit, it will take the input and pass that into the prompt template and then invoke the chain with retrieval chain dot invoke by passing the input. Finally, let's run our loop. Okay. Now save that file and we'll execute it shortly. At this point, we have everything we need to start ingesting PDF files and later on start our chatbot. The only thing we need is a PDF file that we can drop into this data folder. If you have a PDF file, feel free to drop it here and then run the ingestion script. For this test, I have prepared a special PDF file by going to ChatGPT and asking for a little help. I wanted to create a specifically fictional file so that the LLM is surely going to use the data from the vector store. The first question I asked ChatGPT is whether there are dolphins in Lake Tahoe. And clearly there are no dolphins in Lake Tahoe, but with a little bit of help, ChatGPT is able to generate a fictional story for the Lake Tahoe dolphins, including their habitats and their breeding and feeding habits, the other biological information about the animals. We can copy this content and paste it into a Word editor. On my Mac, I have Pages, so I can copy and paste this into a Pages document. The important thing here is to be able to use an editor that can export this as PDF. So once in Pages, I can just go to File, Export to PDF. From here, I can just pick the default settings and save this into my data folder as dolphins.pdf. Back to Visual Studio Code. Now in my data folder, I have dolphins.pdf. By clicking on it, I can view the contents of the PDF file with a special extension. So this PDF looks good and it's ready to be ingested. We can go and open the ingest file and open an integrated terminal. And at this point, we can just type python ingest.py and get the script started. Before I execute the script, let's just take a look at the DB folder and ensure that it's empty. As I start running it, the first thing that will happen is that a new ChromaDB file will be created. And then the dolphins file will be renamed to start with _. Once this database is created, you can actually expand it and pick Chroma SQLite 3 and right click on it and click Open Database. In order to view this, you need a special extension called SQLite. So just go to the extensions, type SQLite, and the first one that comes is good enough. You can download and install it, use it later on to view SQLite 3 databases. So this is our database. Let's take a look at the collections. The first one is our databases. So let's take a look at which databases we have. There should be only one, and that should be the default database. Now let's take a look at our collections. There should also be only one called documents. So this is the documents, and this is our dimensions from our embeddings model. Right. So next, we can take a look at our actual embeddings, and that's inside the embeddings _ full text _ search table. Let's expand this and take a look at our embeddings. Here we can see that we have about 11 embeddings. That's because our chunk size is rather large at 1000. Feel free to explore other collections inside this database, but this is how ChromaDB stores its data inside SQLite. So the ingestion is now done, and technically you can leave this running because the loop itself will continue to monitor the data folder, and as soon as it picks up a PDF file, it will automatically ingest it into Chroma and rename the file to _ so that it doesn't do double ingestion. You can leave this open. I will just kill this for now. And our next script will be our chat script. To run the chat script, simply type python chat.py. The first thing the user will see will be the prompt. You can type Q, quit, or exit to end this loop. And here you can start asking questions regarding the document. Let's take a look at our document one more time. This document talks about fictional dolphins in Lake Tahoe, but there is a number of detailed items here that we can ask. For example, they were introduced in 1975. There is a scientific classification in their names. There is unique traits, a life cycle, birth weight. There's quite a number of fictional details here in this story. So you can just copy and paste and ask the model various questions and just test its ability to answer the questions accurately. I've prepared a quick script with some questions and answers, so let's refer to that. Here is qa.md. You can also find this inside the GitHub repo. So the first question we're going to try and get an answer to will be how many visitors come to Lake Tahoe each year specifically to interact with dolphins. So let's start with that question. The model, helped by the RAG, is able to accurately identify that over 50,000 visitors each year come to Lake Tahoe to interact with the dolphins. Second question, what are the Lake Tahoe dolphins known as? And this is largely for the scientific name. And again, the model is able to identify the name accurately from the RAG information provided. What is the birth weight? It should be approximately 40 pounds. And yes, the answer again is accurate. For this, we are using the Llama 3.2 as a chat model and mxbai-embed-large as our embedding model. They're both from the Ollama's website. What is the diet of the Tahoe dolphins? Primarily of lake trouts, smallmouth bass. Looks pretty accurate. It even provided how many pounds per fish per day. That's pretty good. What is the hunting technique? Let's see what the answer to that question will be. This time, unfortunately, the model was not able to get the right answer to this question. Sometimes depend on the size of the chunks, but also depend on the model itself. So it may be helpful to experiment with other models such as Llama 3.1, Mistral, or OpenAI. And that's why I included some of the OpenAI models. Embedding models do matter, as well as the LLM itself, the chat model does matter as well. So this question, the model wasn't able to answer accurately. Okay, that's for this quick test. Now, let's take it up a notch. Ingesting a single PDF file was fine, but how about when you have tens or even hundreds or thousands of PDF files? How would you go about that? For this test, I've created a simple file which uses a library called PyPDFLoader to scrape a website and create PDF files out of the contents of the HTML. I've selected the OWASP website and created 10 links from the website. Let's take a look at the website itself. And here are some HTML pages. If you click and look around, there's just mostly plain text, but this is ideal to convert to PDF and try to ingest into our vector store. Going back to Visual Studio Code, here's the script. And once we run this, it will create 10 PDF files inside our data folder. Later, we'll ingest these files into Chroma and then perform some queries in our chatbot. Open the integrated terminal and type Python HTML to pdf.py. And now the script has started. And as you can see, the first page is already here. We can take a look at the PDF and it's the first link in the list. Now we have our second page ready and page 3. And now all 10 pages have been scraped and PDF files created. Now let's go ahead and ingest these files. But before we do that, I'm going to go ahead and delete the current Dolphin database so that the two documents don't confuse each other. So I'm going to go ahead and just delete this database altogether. And now I'm going to run the ingestion script, Python ingest.py. And as you can see, pages are being processed and renamed at the same time. All 10 files have been ingested now. I can go ahead and kill the script. We can launch the chatbot. Okay, now we can ask questions regarding the OWASP secure coding standards. What is the CIA triad? The answer is correct and it's fairly comprehensive, giving a lot more detail from multiple sources this time, not just a single PDF file. Now let's go ahead and ask our second question. What is security by design? And again, fairly comprehensive and good answer for the security by design definition. What are some of the principles of cryptography? And here, the model struggles a little bit. As I mentioned in the previous example, not every question will be answered with 100% accuracy. Some questions are just simply missed. And that really depends on sometimes the embedding model and sometimes on the chunk size. This particular one was not answered correctly. Let's move to the next one. Let's see if we can identify the OWASP top 10. It struggles with this. This question was not answered. What are the software security requirements maturity levels? Okay, so this is a good answer. Evaluation, build security, ensure proper. So this does work. Let's move to the next one about the risk rating methodology. Here for the risk rating methodology, number 1, identify a risk. Number 2, factors for estimating likelihood, as you can see. And number 3, factors for estimating impact. Really good detailed answer. So this last one was able to identify an answer in a great way. All in all, I'd say 60, 70 to 80% accuracy. More refining of the parameters could yield better results, but Keep in mind that we're almost using the smallest models both for the LLM and the embedding models so that it runs on a local laptop. If this is put into production or into a RAG pipeline, there is a good chance that you might want to use production grade models such as the OpenAI models. Referring back to our OpenAI models, for instance, you may want to use something like Text Embeddings 3 Large or GPT-4. Those will likely yield better results. And in a future video, I'm actually going to compare the outputs of OpenAI embedding model as well as a Ollama embedding model, and then do a quick comparison, 10 questions side by side to see how the two are performing. But with this setup, so far, both free open source models, quick models, we're able to receive 70-80% accuracy rates. Okay, that's it for today. I hope this was a good investment of your time and you learned something new. If you have any feedback or suggestions, please post them in the comment section of this video. As always, please remember to like, share, and subscribe to this channel for future updates. Thank you for watching.